Were you able to find this signal?
for ones that I need to know for biology.
Okay. That's fine. Tell me what you remember.
I remember that the 4 that we need to know is carbon, nitrogen, oxygen, and carbon, oxygen, nitrogen, and hydrogen, I think.
Okay. But what about these numbers here? Let's see if I zoom in. What do some of these numbers mean?
It means that hydrogen only have 1. I don't know what the 1, I forgot what the number of the 1 mean. Has 1 atomic number.
Very good. Atomic number. Okay. So what is the atomic number of hydrogen?
What is the atomic number for hydrogen? That'll be 1.
Yeah. Right there, okay? You can think of this as kind of like the ID badge, okay?
I remember that.
Because this is how many protons that hydrogen has. You know that hydrogen has 1 proton. Okay? Now, you know that everything on this table is what we consider electrically neutral. What does that mean?
Oh, I'm sorry, I couldn't.
Oh, did you want me to repeat what I said? Okay, I said everything on this periodic table is what we consider electrically neutral. What does that mean? Okay. When something is neutral, it means it has no charge, right? Okay, but a proton has a positive charge. So how do we balance that out so that we have no charge?
By making the same 1 for the neutron? Making a negative for a neutron? Or
Well,
1?
think about it. What cancels each other out? Think about math. Okay, let's say you have.
Oh, is you adding 1? Oh wait, no. I'm gonna leave it alone.
You're gonna have a negative charge, right?
Mm-hmm.
So if you have 1 proton, because everything is electrically neutral, you also know that you have 1 electron.
Oh, it's
Cancel
electron.
out.
Okay.
You have a net charge, nothing, neutral. Okay? That will change as you do different kinds of bonding. But when you first look at it, everything on this table, until you start playing around with it, is electrically neutral. Okay? All right. Let me ask you a question. What happens if I add another proton to hydrogen? So let's say hydrogen has 1 proton, right? What if I add another proton? What happens? Is that hydrogen anymore?
It won't be hydrogen, want to be H.
Yeah. It'll be, let's look on the other side. Okay. It'll be helium.
Oh, okay.
Okay. So yes, the thing to take away from this is that you can change the number of electrons in an element. You can change the number of neutrons in element. But you can't change the number of protons. Otherwise, you're going to have a different element. Okay? All right. So that was our atomic number. What is this here?
So that's not the mask, is it? The mass?
Atomic weight.
Wait, oh, it's the weight.
I think so. This is one that even I get confused with atomic mass, okay? But this is an average of all the isotopes of an element. What is an isotope?
Okay, I got a little hint.
That's okay. Okay, an isotope. Remember I said that, you can change the number of electrons, you can change the number of neutrons, but you can't change protons?
Uh-huh.
So, which one of these do you think we're changing the amount of? Oops.
Neutrons.
It is neutrons, yeah. Okay. So, let's say let's look at carbon. What's carbon's atomic number?
6.
Very good, yes. 6, okay. So that means carbon has how many protons?
Okay, what's the P question mark? Is that 6 too?
How many protons? That's a P. Sorry, I'm writing with my mouse. I'm trying to.
Oh, it's okay. So would that be 6?
Yeah. Okay. You know that carbon always has 6 protons.
Mm-hmm.
Now, let's think back to that other chart you did over there. Remember when we talked about the AMU of each subatomic particle? What was the mass of one proton?
1 AMU?
1 AMU, yeah. Okay. So if we have 6 protons, each of them weighing 1 AMU, what's the total AMU, total mass that comes from protons?
So it'd be 6?
Yeah, it would be. Okay. So let's take a look at the mass number, the atomic weight, of carbon. Okay. This is the average of all the different isotopes. Let me give you a couple isotopes I'm going to make up. Okay. So let's say we have an isotope of carbon-12. And we also have an isotope of carbon-14. Okay. This is the atomic mass of that particular isotope. Okay. So 12 AMU is the total mass of this one atom of carbon, and 14 AMU is the total mass of this atom of carbon. Okay. So we know that carbon has 6 protons, and you just said that we have 6 AMU from them. Okay. I want to know how many neutrons does each isotope have? How do I figure that out?
Is that where the multiplication come in at, like the added or subtract or something like that?
Think about it. This is the total mass, okay? Let me ask you a different question. What other subatomic particles can contribute to the mass? So remember you say neutrons weigh what? And electrons weigh what?
So the neutron will be, and the electron is 0.
Okay. So we know, for our intents and purposes, even though they do have a mass and do count toward it, for us, we're going to ignore it, okay? So the only thing, we know that neutron plus proton is going to give us our total mass, right? So if my total mass is 12, how many neutrons do I have?
6, I think.
How'd you get that number?
Because the numbers of neutron is 1 AMU, but in order to get the 12, you got to take the 6 plus 6. Oh, you got to subtract it. Oh, okay.
The shortcut is to take your atomic mass, and you're just going to subtract the atomic number. Okay. What about for this one? How many neutrons does this atom of carbon-14 have? I can't hear you.
So all we doing is just doing the same thing, which is 14 minus 6, which is 8.
Yeah, very good. Not so bad, right? Okay. Questions on that? All right. Now let me ask you something else. What is an ion?
Atoms with charges.
Got it. Can you give me an example?
So like, is it carbon? Atoms that have a charges so the ones that have the plus, right? I think.
Plus or minus, right?
Okay.
What's an example? It's a couple that you want to be at least familiar with. Okay.
Sodium.
Okay.
I don't know the other ones. Sodium.
Well, this is sodium. Yep. What's this one?
Is that chloride?
Yep.
Chloride. I don't know that one.
Potassium. What about this one? Calcium. Okay. Let me give you a little hint. Okay. For some of these, it's going to be an abbreviation of their name, like hydrogen H, right? Helium He, carbon C. Potassium is one of those funky ones, okay? And so is sodium. They're based off their Latin names. Natrium is the Latin name for sodium. So that's why they use the abbreviation NA, because they already have an S. And you can't repeat that.
Right.
Right? That makes sense?
Mm-hmm.
What other questions on the periodic table and understanding that?
Well, I think I got the whole concept of the periodic table, and I just don't understand when it come down to taking the tests and stuff like that. Like all of that, just when it come down to doing a grant, I don't know what we have to do on that test because it was just so much. But it don't. If everything was like how I'm getting told to me, it's not like that on the test. So that's where I'm messing up at.
Does your teacher give you a list of outcomes and objectives?
Does he do what?
Give you a list of outcomes and objectives. Usually they're seen as O's and O's.
Yeah.
That is something you want to use as a short answer study guide, okay? Because everything on that list is what your teacher considers important for you to know, okay? So what a good strategy would be is to use all your resources, use your notes, use online resources, whatever, and answer those questions in as much detail as you can. Okay? Then you're going to print off a couple of blank copies, and every day you want to try to answer some of those questions without looking at your notes. Okay? That's kind of like a litmus test for what do I understand well versus what should I put more time into studying. Okay? You can also try explaining what you're learning in class to someone you live with, to a friend, or something like that, okay? You can also create a Jeopardy game, and I can give you a template if you would like, a blank template, okay? Because that's a really good way of, again, you're researching some answers. You're trying to find out what questions are important, hard questions versus easy questions. And then, when you're done, put it away for a day or two, and then you run it and play it and see how much of that you remember. Okay? The name of the game here is repetition and explaining the concepts. So the more you do that, the better off you be, especially when it comes time for your practical and for your written exams. Okay? All right. Try those and see how they help. I'm also going to try to incorporate those strategies into our weekly study group. Okay? That's why I'm asking a lot of questions. That's why I'm saying, well, can you explain it to me? Okay? I do it for a reason. talk about that. What were some of the questions on your exam that you can remember that kind of stumped you? Maybe if I see how they asked it, maybe I can see, what's going on.
I'm when it comes down to that test, I don't remember nothing because it was just all that. Let me, I can probably try to, I don't know, I can see. That's the
That's
best
okay.
thing I can do because, like I said, I didn't understand any of it. And it was so hard for me to, I just like some of the questions that he had, I ain't gonna be able to do it. I don't know. It was horrible. I just didn't understand how he put some of these words together and then sentences and I don't know. I don't want to talk about that.
For anatomy and physiology, since they know a lot of you are going into medical professions, they are looking for more than just memorization, okay? What they want you to do is they want you to be able to understand the concept, memorize the concept, and then be able to apply those concepts, okay? So that applying the concept means you're kind of testing what you know. Well, if this happens, what will happen? For example, let's talk about ionic bonding. Okay? What is ionic bonding? How does it work? Okay? These are questions you want to ask yourself when you are studying, okay? Make sure you write out what they are to yourself a couple of times. Explain it to yourself. Look up some helpful pictures and diagrams. But sometimes it makes more sense when you can see how something is moving, right? Okay? Was ionic bonding something you had trouble with or you understand?
Um, yeah, that was one of them, and then the other one I had got the buffering and stuff right, but the macromolecules, I think that's what it's called. I didn't understand that, or the phylosaccharide. I don't know all these words.
Okay.
I don't know.
So macromolecules, and what was the other thing you said?
Macromolecules and polysaccharides. Is I'm saying that right?
Polysaccharides. Yep. Okay. So we're talking about monomers versus polymers, right? A monomer is the smallest unit, right? So glucose is a monomer. Let's see if we can find a picture. Give me 1 second, okay?
So you said monomer is a unit of molecules, a subunit?
Yeah, because you have a couple of different categories, right? You have carbohydrates, you have fats,
Mm-hmm.
you have proteins.
Mm-hmm.
What was the last one?
Protein. So fat. Oh, I know this one. It was fat, glucose,
Not quite yet. Like, we're talking about 3 classifications. Okay. Let me see if I can switch to my whiteboard. Okay, so we have 4 categories, right?
Mhm.
Go ahead and look in your notes if you want, but we have carbohydrates,
Protons, lipids, and nucleosides. Is
I'm
that
sorry,
right?
say again?
Carbohydrates, protons. The lipids is the fat, right?
Lipid is fat. Yep, lipid is fat.
And then the nucleic acid.
Nucleic acid. And zoom out so we have more room. I'll write that. Nucleic acid. Okay. Good. Now, we have monomers, which is one single unit of that. Yeah. A single unit of something. Huh? All right. What is a monomer of carbohydrate?
My notes say single sugars.
Yeah. It's
Okay.
glucose, okay? And they usually look like rings. So let that be clear. It usually looks like a ring. Let's see if we can find some examples online to really drive that point. I'm a visual learner. I like seeing things. You are too?
Like I can read all day what my notes say, but then when it comes to me trying to visualize it and stuff like that, I don't. It's just blank, blank, blank.
I understand. That's why it's helpful to like draw it out. Or if you take a look at them all together, try to see what differentiates, right? And I spelled that wrong. But here's some monosaccharides. Can you see something similar between all of them?
Something similar is they all have the CH2OH. I think if that's similar.
They've got a lot of H with a little bit of O and T. They're all in rings, okay?
Oh, they all in rings too, yeah.
Let's do that. So rings with a ratio of about 1 to 2 to 1. Carbon to hydrogen to oxygen, okay? When you see these rings, you know it's going to be a carbohydrate. Let's go back. Okay. What is the word for when you have 2 of them? So not monomer, not polymer. What's the word for 2 of them?
Is that the bi? No, it's not.
It's probably a di something, isn't it?
I don't know.
Disaccharide, okay?
Oh.
Saccharide, we're going to be talking about carbohydrates. So anytime you see saccharide, it's carbohydrate. Okay? Di means 2. Saccharide is sugar. So 2 sugar.
So you said anytime I see saccharide, that is the carbohydrates. Is that what you said?
Yes, so you can,
Okay.
when you see saccharide, more often than not, it's going to be related to carbohydrates.
Okay.
Okay, so these are disaccharide. What can you tell me about this? You sounded off.
I don't know.
Okay. They have two rings.
Besides, yeah, okay. The two rings. I don't ever think about the two rings.
Okay, here's some two rings. Let's take a look at polysaccharides. Ooh, what about this?
I
Poly
got
means,
three.
poly means many.
Okay,
So
many.
anything above
Okay.
two, you're going to call polysaccharide.
Okay.
Does that make a little bit more sense? Okay. That's why visuals are great. All right. Talking about this. What's the monomer of lipids?
So when you say what's the monomer of lipids, I know lipids mean fat. So would that be the monomer?
There's a name for it, okay? This is right, okay? So here is a triglyceride, right? Here's a glycerol backbone and the three fatty acids coming off of it. Okay? Okay? You're going to see this is a monomer, but you'll see a bunch of them together if it's a polymer, okay? And so we covered lipids, we covered carbohydrates. What we got left?
I couldn't hear you.
Oh, can you hear me now? Okay. What is a mono? What do we have left to talk about?
So is we still on the micromolecules? So is we still doing like the protons and the nucleosides? It's all that's left we didn't talk about.
Still on the macromolecules. We talked about carbohydrates. We talked about lipids. There's two more we have to talk about.
So that's not the proteins?
Protein is,
Okay.
yes, that's one.
And then the nucleic acids?
Let's take a look at what that looks like.
Okay.
Okay. So we have amino acid, right? Okay. So there's a couple of things. The sound is off, by the way.
So because I remember in the test, it always talk about the R group. So when they talk about the R group, they talking about the proton,
Protein.
basically, something like that.
You see an R group, a carboxyl group, and an amino group. You know you got a protein. But what about the other one, nucleic acid? You have a nucleotide. Okay, so you have amino acid, which is a monomer of protein. Amino acids are like building blocks of proteins. You put a bunch of amino acids together, you get a bigger protein. Okay, but for nucleic acid, we have a nucleotide. Okay, so you have a 5-carbon sugar. Remember that ring of carbohydrate? Okay, you're gonna have a nitrogenous base and a phosphate group. If you see a phosphate group on it, like this, with a nitrogenous basis, you know it's not a protein. Okay? That makes sense?
Yeah, it makes sense. It makes a lot of sense.
That's why I highly recommend if something stumps you, go look up a picture of it. Because sometimes seeing it represented visually makes a lot more sense. Okay? Alright. Questions on that? Alright, so we covered chemistry, covered macromolecules, and maybe we can talk real quick about cell structure if you would like. We only have about 5 minutes left, okay? So let me pull open my list. Alrighty, cell organelles. I'm using a memory trick to help me remember all of these. I'm going to show you how in a minute, but let's start off with the Golgi apparatus. What is that, Jim?
What is who?
Golgi apparatus, also known as the Golgi box. What is its function? Okay, let me ask you a different question. What is the function of FedEx?
The function of
To package and transport goods, right?
uh-huh.
That's what the Golgi apparatus does. It packages and transports proteins. So you can think of the Golgi apparatus like the FedEx of the cell. Okay? I find real world comparisons for some of you make it a lot easier to remember. Okay? What about the plasma membrane? Plasma membrane. What's the function of the plasma membrane? Go ahead and take a look at my little diagram. What do you think?
It looks like it could be like a DNA or I don't know, a train. I can't. I don't know. I don't know.
That's okay. The plasma membrane is the outer membrane around the cell. Okay? It's called a semi-permeable membrane. I like to think of it like border patrol. Border patrol lets some people into the country, but prevents other people from coming in, right? That's exactly what the plasma membrane does. It lets some things in, and some things out, and some things it doesn't let in or out. Okay? So it controls what can come in and out of the cell.
See, like some of these words I haven't heard of, or like I haven't got to them just yet because I just.
Oh, okay. So am I jumping ahead? Then?
No, if you're jumping ahead, that's fine because they give me an example of what some of these words mean. Like the what was it? The apparatus.
Golgi apparatus.
Golgi apparatus. Okay, so I never heard of that. So I probably haven't got to it just yet, but you give me an idea of how I can describe it and how I can use it or to remember it.
So when you're going through and learning the different functions of these organelles, see if you can try to compare it to some real world example. That'll help you remember, okay?
Okay.
Because you're going to remember some of these things a lot better if you connect it to information you've already memorized, right?
Right.
I used to work at FedEx. That's why that example made a lot of sense to me.
Okay.
Because I would be packaging up all the broken boxes, and then we'd be shipping them out to our customers. So try to pull in some real world examples from your personal experience.
Okay.
We are almost out of time for today. Is there anything in particular you'd like to cover next? Or is there any of the materials that you would like me to send you that we were using?
No, I think I'm pretty comfortable now with my module 1.
Good.
I think it's probably like some stuff I need to go over, like the synthesis,
Okay.
and stuff like that. But
Like dehydration synthesis?
yeah.
Okay.
Yes. But I think, and covalent bonds, I want to go over that too if we can a different day or something.
Covalent bonds, dehydration synthesis.
And I'm pretty good with the primary, secondary, and the protein structure. I'm good with that. Yeah, I remember that really good. So yeah, it was just certain things that I just didn't understand. But if you can help me with those ones another day or something like that, that'd be helpful.
You got it. That's what this is for. Okay. Thank you.
Thank you.
You're very welcome. Okay. Anything else before we close for today?
Nope. I think next week this week, because I think you say the next day is tomorrow.
Mm-hmm.
So if I put down a meeting for tomorrow, like a one-on-one, can we talk about those things? Yeah. And then for next week, can we jump to module 2? Because I'll be done doing that, but then I know that I have a test coming up soon and I want to, refresh my memory and make sure I got everything like that good and done with.
Always a good idea.
Okay.
Do you know how to make the appointment for one-on-one?
Yes, I do now.
But I will see you tomorrow, okay?
Okay, thank you.
You're welcome.